Hey guys, welcome to another video. What I'm going to do in this video is still continue on some differentiation stuff. I've just got a previous video if you want to have a look at some just basic differentiation. But what I'm going to look at today is just some different ones that involve some radicals, some square roots, cube roots, and things like that. We start to introduce fractions into our indices. Okay, I'm also going to look at one example where you've got a derivative of two different functions summed together, or the difference of them, and how to find that. So we'll look into that as well. Okay, so here's our first one. Let's jump straight into it. I've got my first function here and I want to differentiate this. Now the concept's still the same, so I'm going to multiply my power with my coefficient at the front, and I'm going to subtract one away from my index. Now the fractions always fool people, it freaks people out. They're like, I don't know what to do with that, but the concept's the same, so let's try it. So let's do half times a third. Now if I put that to the side here, you don't have to show this when you're working it out. 1/2 times 1/3 equals 1/6. Okay, so f prime x is equal to, so it's going to be 1/6 x to the power of 1/3 take away 1. Now people, please don't say it's 0/3. This is going back to really basic fractions. So remembering that 1/1 can be written as, 1 can be written as 1/1, but we want the denominators to be the same. So let's change that. That's the same as 3/3. And then we keep our denominator the same. 1 take 3 is -2. So that means my power now becomes negative. Now you can leave it like this, but as mentioned previously, you always want to try to leave things as positive indices. So what we're going to do is we're going to move this to the bottom of our fraction. So I'm going to be left with 1/6x to the power of 2/3. Now this is also a very fine format. There shouldn't be anything wrong with this. However, what we want to do is actually convert it with a radical. Okay, so for what a radical is a fancy word for a square root sign. So let's try and do that. So if I bring this actually over here, so I'm just showing all of the workings, by the way. I'm really trying to break it down. So just be mindful, even though it's a bit messy, it's just for you to see. Okay, x to the power of 2/3, that's the same as x to the power of 2 times by 1/3, if you agree, because imagine that's over 1, it's 2/3. Okay, so I've just broken it up a little bit there. Okay, now that's the same as x squared to the power of 1/3. Okay, now when you see this is the same as a cube root. So what we're going to do is put the cube root and put the x squared underneath. So essentially this is the same as that. Okay, so this format here is a nicer version of this. So let's rewrite it, our answer, in that format. 1/6, it was a cube root of x squared. And that, my friends, is our final answer. Let's jump into our second one. So our second one here is y equals 3 root x. So let's rewrite this. I always find this really difficult to try and differentiate because you're like, I don't have any power. So let's write it with a power. So the square root is the same as a half. Okay, so similar to how a cube root is the same as 1/3, the square root is just the same as a half. Okay, so now it's in this format. Let's just try and differentiate. So y prime is equal to 3 times by a half. 3 times a half is 3/2 for those who are wondering. So 3/2x. Now I'm going to take one away. Similar to before, we can rewrite this as a half. Take away 2/2, which is -1/2. Whoops, that looks kind of blended together. Let's rewrite that. Now this is the fine answer, but we want to represent in positive indices. So let's bring that x to the power of a -1/2 to the denominator. So it's positive. Fine answer. Let's put that radical back in. So let's change that half to a square root, and there we go. That is our final answer. Let's go to example 3, shall we? Let's move. Here we go. Similar thing. Now we've got that same situation, very similar situation to what we had in our first question. So let's try and fix this up because we want to show the powers. So f of x, because it's not prime yet, by the way, because we're just changing the format of our question. We're not actually differentiating yet. This is 2x to the power of 3 to the power of a half, because anything that's square rooted is the same as a power of a half. Okay, so let's actually use one of those index laws where we multiply those indices together. So we get rid of that bracket. That becomes 3 over 2. Okay. Let's start differentiating now. This is in a format that we like. We like this. We've got a clear coefficient and a clear power. The coefficient times by our power, those actually cancel out. So the answer is 3. So let's write that in. 3x to the power of, what's 3 over 2? Take away 1. I'm going to write it as a denominator of 2. Just to make it easy for us, because we already know that's what we're going to need to do. If you saw the previous 2 examples, the same as a half. That means if I change that into with the radical, it is 3 root x. Both of these are the exact same thing, but one is just written with the square root sign. There we go. Here's our next one. Starting to get slowly a bit funkier, if that makes sense. Let's look at this and rewrite it. So I'm going to rewrite this again. Like I said, I'm not actually differentiating yet. I'm just putting it in a format that's differentiation friendly, I guess you could say. So this is 3 over x power of a third, because anything that's cube rooted is the same as a power of a third. Now this has got a denominator. I want to bring this up on the top. So I'm going to make it a negative index. So 3x to a negative third. Now it's got the clear coefficient, clear power. Let's differentiate. 3 times by a negative third. Those cancel out. You get negative 1. X to the power of negative a third, take away 1. I'm going to write it as the same power, same denominator to make it easy. Negative 1 take 3 is negative 4 over 3. Okay. Oh, let's write our little differentiation there. Okay, so this is fine, but we want a positive index. So let's move that to the bottom, shall we? Move it back. Now, this is a fine one, but I want to try and write it with the radical back in, because we got rid of it to start off with, but now let's turn it back into that, because that's the format that we were given in our question. I'm going to now break this down. So if you have a look, that's the same as x to the power of 4 times by a third, which is the same as, so let's put a cube root there. So that's negative 1 over cube root x to the power of 4, and that is our final answer. Lovely jubbly. Let's do one more. So here's our next one. Now you can see here I've got no radicals. This is the one I wanted to talk about, because you've got two kind of different functions put together. It's not just, it's not just that bit there. You've actually got two separate functions here. What's nice about differentiation is that you can split them up and then put the answer together. Okay, so let's do that. So if we had y equals 2x to the power of 4, and you had y equals 3x to the power of 3, let's just differentiate them separately and put our answers together again. 2 times 4 is 8x to the power of 4 take 1 is 3. So that's one answer. It's not the final answer, but it's one of the answers. 3 times 3 is 9x to the power of 2. Let's put it back together. So we split it up. Let's put it back. That means y prime. Sorry, I need to keep my notations there. Y prime, or the differentiated answer, is 8x cubed take away 9x squared. That's our answer. Just be mindful, I've split them up and then put them back together again, but some people are very good at just putting it in one step. What you could do is go straight into it and just go, okay, 2 4s are 8. Let's put our takeaway sign in and do it straight like that. That is absolutely fine. I'm just splitting it up just to show you that you can if it gets really tricky. I like to split it up separately when you've got some really difficult things to differentiate, and makes it really clear versus doing it in one step. But it's just for you to know. All right, that's all from me for this video. Thank you for watching, and see you next time. Bye.